In this chapter, we'll talk about the nature of econometrics and economic data. There are four aspects to this chapter. The first one is about econometrics. What is econometrics and its purpose and its scope? The next aspect is to take what we learn in economic theory to some sort of an empirical analysis. And maybe not even economic theory, just our economic intuition about the world around us and how do we take that to empirical analysis. So essentially, this is about building an economic model, but this time with data, right? And that's really the difference between theory and empirical analysis. The third aspect is to learn more about economic data, the structure of economic data, and the types of data sets that economists, business analysts, or other social scientists encounter in their day-to-day lives. And last but not the least, we will get into this intuitive discussion on causality. You must have heard about this debate between correlation and causality, or correlation is not causality. And so we will get into this intuitive discussion on causality, the difficulties that we encounter when we are doing statistical inference, and also how important is this notion of ceteris paribus, which is to say that all other factors are kept constant. So if you're thinking about a relationship between two variables, let's say y is a function of x, for example, wages and education. So x is education, y is wages, and you want to somehow estimate the effect of additional years of education on wages, then how important is this concept of ceteris paribus? Everything else that might affect wages other than education should be held constant. So we'll talk about that. So when we think about econometrics, this is really coming from, at the heart of it, there is mathematical statistics. And if you combine statistics with different fields, if you combine statistics with econ, it becomes econometrics. If it is combined with, let's say, psychology, there is this field of psychometrics. If it's combined with biology, for example, it becomes biometrics, right? So really at the heart of it, there's a lot of statistics that we'll talk about. So in econometrics, we really think about a set of statistical methods or tools that we can learn that are really important to economists or other social scientists to analyze data. But what makes econometrics different than these other fields is that in econometrics, we are really trying to estimate these economic relationships that we know might exist. We are able to test economic theories and even our economic intuition, and also evaluate important government and business policy. So government policy would mean some sort of fiscal policy or some sort of monetary policy. Okay, so there are some examples you can think about. If you were trying to estimate the effect of school spending on student performance, then you might be asking an econometric question. And you might want to hold other factors that affect student performance constant to estimate the effect of school spending. Similarly, if you were interested in, let's say, estimating the effect of political campaign spending or expenditures on voting outcomes, you might want to hold everything else that affect voting outcomes constant. And finally, if you, as another example, if you were interested in looking or estimating the effect of Groupon is a company, a medium-sized company. If you wanted to estimate the effect of a Groupon on, let's say, a yoga studio's sales or revenues, you could even do that using econometrics. Okay. So really, at the heart of it, I want to emphasize that econometrics is really its own discipline. It's different than mathematical statistics, even though we borrow a lot of tools from there. But really, it analyzes data that is generated by some sort of units. And these units could be individuals, firms, states, countries, households, schools, etc. And these units are always acting strategically and interacting with one another, which is what makes econometrics very interesting. Now, there are, broadly speaking, two types of data that you might encounter. One is called experimental data. This is very typical and very easy to find in the hard sciences. So in maybe a physics lab, a scientist might be collecting experimental data, or in a chemistry lab or in a biology lab. But in economics, these experimental data are hard to come by or are rare to find. Okay, some examples do exist, but these are data that are essentially from some sort of controlled experiments. And if you know anything about economics or the economy, it's hardly anything's happening in a controlled setting. So these experimental data are hard to come by, or these are, in other words, rare in economics. So what do we have? We actually, in economics, have greater or larger access to non-experimental data, which we also call observational data or retrospective data. And the reason we call these data observational are because these are sometimes collected in a very passive manner. We are maybe observing some sort of outcomes on individuals, on families or households, firms, schools, states, or countries. So we have all of these units and we're observing them. And then we're trying to maybe ascertain, what do we learn from the different data that we've collected, and are there any relationships that we can think about? Okay, so just to kind of summarize this slide here, that experimental data are hard to find in economics, although some examples exist. But we usually have non-experimental or observational or retrospective data that exist in economics. Now, one question might come to mind: why study econometrics? So one thing to remember is that studying economic theory and building your economic intuition is great, but we really need to test it out in the real world. Okay, so we can actually apply what we learn in economic theory to the real world data, or this non-experimental data that we were talking about. Maybe what we want to do is estimate the effect of some sort of policy change. So it could be as simple as, when you think about what some of the maybe it was New York or some other state on the East Coast, they were trying to give incentives to people to get vaccinated. So in other words, you could basically walk into Shake Shack, a very popular burger joint, with your vaccination card, saying that you've got your 2 shots, and they would give you a free burger and maybe a beer, right? So if we wanted to see, did that have any effect on people getting vaccinated, or did the vaccination rate increase after that policy change? We can really use our econometric skills to answer such a question if we had data on that. Okay, so what we can do is measure the effect of that policy change. And sometimes we can also try to understand how large that effect might be, large or small that effect might be, right? So are we making sort of a marginal difference with policy, or we are making some big changes? And lastly, we might be interested in using this data to forecast. This is something we will cover next semester when we do time series. But some of the variables like GDP, inflation, interest rates, some of the macro variables like housing starts, and so on and so forth are important as well, because these data guide policy decisions and also sometimes tell us about, did the policies work to maybe increase GDP growth or keep inflation under control, or there was did housing starts accelerate, and so on and so forth.